This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Podcast. I'm your co-host, Dan Blewett. On today's show, we're going to talk about a scary cell phone fire that happened on Alaska Airlines and some of the unique methods that their crew and their company in general have developed to mitigate those lithium-ion battery risks in the cabin. We'll talk about a Viasat potential Wi-Fi problem on some 737s, and we'll also chat a little bit about some good news that Emirates Airlines is reestablishing pre-COVID salary levels and benefits as of October. And then our EVTOL segment, we're going to chat about DuFour's. They have a tiltwing design EVTOL that looks pretty promising. And we'll also chat through a little bit more Archer news lately. So, Alan, talking about cell phone fires, this seems really scary. And so Alaska Airlines has developed in-house this crazy, it's like a thing for their crew where they basically have these two high temperature, what look like silver oven mitts, and this pouch that they can deposit a cell phone if it blows up. Not necessarily blows up, but if it catches fire. Is this something that, it seems like this should have been in existence a long time ago, but it seems like Alaska Airlines is kind of on the forefront of this. Is that how you read the article?
Yeah, and I haven't ever seen that type of technology on an airplane before, which is weird because I usually see all those oddball things. But the cell phone fire bag is a new one to me. And it must come along with some level of training for the flight attendants, because I can't imagine in your first time there's a cell phone fire, you're going to put those oven mitts on, start grabbing at a flaming cell phone. I'm not sure that would be my first thing to go do. So it must involve some training. And it in this particular case, because they had a cell phone fire on an aircraft on the ground and everybody hopped out on the fire escapes, it makes a lot of sense to have something to engulf the fire so you don't, in a sense, set other things on fire in the cabin, which would be even a worse fire. So this is really an interesting proactive device system that I have not seen on other airlines.
Yeah, and it looks like the bag was made by Baker Aviation. It's called the Hot Stop L, and it's proven fireproof up to 3,200 degrees Fahrenheit, which is crazy. And the we're referring to them as oven mitts, but that's what they look like. They just look like gloves, obviously, but they remind me similar to what you'd see workers at like a foundry, they wear when they're like stoking the flames or handling anything. Like they have these huge fireproof mitts. And so it sounds like, this company, Baker Aviation, along with Alaska Airlines, worked together to get that done. But yeah, so apparently, the big challenge of lithium-ion fires is just how hot they burn, that they get really, really hot. And so they said in this article that previously crew would have to just find a place for it somewhere on board and just like put it somewhere, which is just crazy to think about. But yeah, I guess you can't anticipate everything.
The scary thing I would assume is that if you don't have any training in it, my first response would be to flush it. To try to get it somewhere and douse it in water, and which is not going to really do anything in a lithium fire. But that would be my first instinct. I think everybody's first instinct is to hit it with water, throw some ice on it or something. But it really wouldn't do anything in that case, and it would probably endanger loads of passengers at the same time. So this is a really interesting solution. Isn't it odd that we've never seen this before? I've never seen it.
Yeah, and it also just strikes me as strange that it could burn that hot, up to 3,200 degrees. That's what the bags can withstand and not melt. But then again, there's a lot of fabrics that, we've been discussing, fiberglass and composites. There's a lot of materials that look like a fabric that can't melt. So I think that's just kind of a perception thing. But I know like on a cabin, there's obviously as much as made out of metal as possible, within reason, because you don't want to make the plane heavy, but you see all the things that need to last 20 years, all the little, knobs and things that would be ordinarily made of something cheaper are made of, aluminum or something really durable. So you think there would be some metal cabinet you could throw one of these in. But then again, 3,200 degrees could probably melt aluminum. I don't know the melting point of aluminum offhand. Do you?
Yeah, it's above the melting point of aluminum in Fahrenheit. I think that is. Yeah, I think the melting point of, yeah, I think it is. Off the top of my head, I think that it is. Yeah, but it's so hot that I think in a cabin area, it's not so much the pieces that are certified with the airplane. It's all the other things that come into the cabin, which are paperwork, books, things that readily burn. And if you happen, like a lot of people do who are traveling, if you have a bunch of paperwork and you have your cell phone in your bag and the cell phone lights up and it lights off the paperwork in the bag, now you have a serious situation, because smoke inside a cabin is not a good thing. And you're immediately declaring an emergency, right? And so getting this thing squashed as fast as you can is the right way to go. And I think part of this is I've never seen this used on a business aircraft, and I would think that a business aircraft like a Cessna Citation or a Gulfstream 5 or Bombardier, like a 7500 or something like that, would have the same issue, just because if you have a cell phone catch fire, it doesn't regardless of what the airplane type is, that's a big deal. Yeah, it's just fascinating to see this.
Yeah, well, and what's also interesting about this flight was that this battery fire broke out shortly after landing. So they were done, which is, I'm sure, to the relief of everyone, this didn't happen at 30,000 feet. But at the same time, it seems like also just such a weird timing that, it's almost like, you're like so close to the bathroom and you just can't make it. Like the phone just couldn't make it, to get out of the, but, so they had to evacuate the thing. But you wonder what would happen if this was at height. And of course, what's interesting is they have not just like a small bag, they also have a bigger bag for the crew, for the pilots to have their laptops in case this happens. So it seems like it's going to be probably a ubiquitous solution going forward, rather than having some, because what do they have in the belly of the plane, Alan? Don't they have like
They have smoke alarms. They have smoke alarms, and sometimes there's some fire suppression down there. Depends on what kind of airplane it is. But yeah, but if the smoke alarms go off in the cargo area, you have a serious problem. You need to get to the ground as fast as you can, because you're never really sure, one, if you can extinguish it, if there's an extinguishing system, and two, how long you have, right? So it's a problem.
Well, no, my last question to you is, I know the planes turn over their indoor air really, really fast, like every 2 minutes. Because it seems like the fumes are one of the really big issues here, right? I mean, you have crazy toxic fumes coming out of a battery, just burning until it's out. So that's my other thing. I'd love to see this bag in action. Like, what does it do with all the fumes? Because there's going to be expanding gas, right? I don't really know how that works. Like, wouldn't it just get to the point where it would burst and fumes would come out? Or maybe fumes can't be contained in it?
The fumes are not going to be contained in it, and they'll come out. What tends to happen in fire situations, that you want to remove smoke from the cabin and cockpit. And so there's a bleed air system which pressurizes the cabin. You want to just unload that. And so you're just going to basically get yourself down to an altitude, and you can just let the cabin pressurization go and just push as much volume of air through the cabin and cockpit to clear the smoke out. That's the trick to it, is that you just want to get to maximum airflow to shove the smoke out so you can see. Because if you can't see, you really can't save yourself.
Huh. Okay. That's interesting. So, yeah, pretty crazy situation, but it's good to see there's interesting new tech that's mitigating these scary. I mean, that could have happened, like you said, could have happened in the middle of the flight. Thankfully, it didn't. All right, so moving on, interesting article about Viasat Wi-Fi radomes that are being removed from El Al commercial airliners from their 737 jets. So it sounds like, obviously Viasat providing Wi-Fi on these flights, it sounds like this could potentially cause damage to the fuselage, and the FAA is requiring these to be pretty much taken off immediately. Alan, this sounds like the FAA is moving pretty fast about this. It's not just like a advisory, it's really just like hey, these need to get removed ASAP. I mean, is that how you see the situation?
Yeah, the article about this El Al situation was really interesting, because you don't typically see the FAA mandate a removal of a component, or in this case, almost a piece of structure off the aircraft, usually there's an inspection done on the aircraft that are in service that may have the same installation, because the issue is cracking. And if you're on an aluminum fuselage and you've installed something relatively heavy on top of it, and you bolted it into the airframe structure, what you're looking for is if there's any flexing or fatigue that's happening, it's causing cracking, because eventually that'll let loose. And in this particular case, the radome could come off and hit things behind you, like the vertical stabilizer, which would all be bad. But on other installations, what has been done when they've seen this sort of fatigue-related vibration, and I think this is somehow vibration related to aerodynamics, what they've done is sort of stiffened up the structure to alleviate it or to fix the aerodynamic problem. I've not seen mandated removal of an installation, so this is going into a different territory. And until we get more details on it, we're not going to know for sure. But so you would think structurally you'd be able to you'd be able to repair this or modify the installation to bring it into compliance. Why the sort of forced removal is fascinating. Now, it did sound like El Al had found the cracks themselves and identified it and alerted everybody about it, which is the right way things are done. If you do see this generic problem, and if it's beyond one aircraft, you see it in 2 or 3 aircraft, you need to alert people, because this may be something a little bit wider. And they did do that, but what's driving the removal? And are they going to be able to put another system on? Is the airframe not able to support this kind of load? All this is just bizarre, because I know, having worked on these aircraft radome installations, I know there's a lot of work done and analysis done on the structural implications of this massive radome structure going on a little support structure. There's a lot of structural analysis that happens. So it's surprising that the FAA would say you missed so far that on the analysis and structural view that you got to pull the system off. That's what it feels like now. But that would just seem really unusual.
Yeah, and like you said, good for El Al for catching it. Just through routine inspection, because otherwise that was be my question to you, is like, how do they figure out some of these things? If this was, this article says that no U.S. registered aircraft are carrying this technology, so there's no U.S. carriers affected. But I mean, like, they don't just disassemble all these planes just in routine maintenance. I mean, how rare would it be, like, if this was cracking and this was a widespread problem? Would this just be something that could go unchecked?
It wouldn't go unchecked for very long. There's certain intervals in which the airframe has to be inspected, and that involves really disassembly. I mean, at some points, there are some levels of inspection where you're pulling the engines off, you're emptying the fuel tanks, you're taking all the interior out and looking for things like this, cracks. And particularly on these radomes, if you think about the way the radomes go on top of the airplane, they kind of cover all the structural fittings and interfaces. You really can't see them from the outside. The only way to see them is to pull the radome off and look in, or to go inside the cabin and start taking off all the headliners and all the accoutrements that make up a cabin, and look in and try to see if you can see the cracks. So there have been some standard check, and every radome installation like that has a maintenance manual that comes along with it that defines when you need to go look and what kind of inspections you're going to perform and what intervals you're going to perform them. So my guess is that El Al was just doing routine inspections as called out in the maintenance manual, and they saw this issue pop up. Now, I guess there's another question about it is, how much time is on the airframe? Is it an airframe issue that the airframes are older and maybe they can't support these kind of installations because the airframes are older? That may be part of it too. So it may not necessarily be that the installation is bad as much as the combination of the installation of the radome plus the airframe age leads to these kind of problems.
Well, some good news. Emirates is set to reinstate employee salaries and benefits. So it looks like they are maybe through the tough part of the pandemic, and they are ready to give people back their full salaries. Because I know a lot of companies, gave just a reduction. Obviously, there were some layoffs, some furloughs, some firings, all that. But it looks like UAE is ready to get back to normal. Is this a sign that all these airlines are going to start to follow suit, or is this maybe just an outlier?
I think they're trying to get back up to speed as much as they possibly can. If you look at the TSA numbers for the number of people actually going through security, which gives you a sense of how many people are flying, I think we're at like 70%, 75%, somewhere in there in the United States. We're still down a good 20 to 30%. And I would guess that extends worldwide. I think in terms of just retaining employees and having a functioning organization, you're going to have there's some minimum level in which to operate an airline. And beyond that, below that, you're just not functioning safely. And a lot of airlines did reduce salaries temporarily. There was a lot of going back and forth. And in particular in the United States, the federal government stepped in and provided funding to the airlines so they could keep employees on staff. I think UAE and Emirates and all the others are trying to do the same thing. Outlook, I think, Dan, this is sort of more of a play looking forward a little bit, because if you bringing back employees and bringing back to full salary, there's an anticipation that the airline's going to be operating at 90-ish percentile of where they were previously. I'm not sure we're quite there yet with this Delta variant going around. When we're going to be there, it's looking like the end of this year, December 2021, January 2022 is when things may start to feel a little more normal. But it is a good sign. I just haven't seen that sort of step up in airlines in the United States yet. And I think there's a lot of like Air France and Lufthansa and some of the others are starting to come up, but maybe not to that level yet.
Yeah, I know the U.S. seems to be recovering and flights are going up, but they're still not. I think one of the bigger things here in the U.S. is that a lot of flight attendants are exhausted. A lot of the overall airline crew are just exhausted. And, there's been some public backlash against Southwest recently that people were just overworked and fed up at the way the company is not really showing support for them. And I think that's been a common thread throughout many, many industries, air, commercial air included. So I think people are I shouldn't say they're more likely to tolerate bad treatment when they're fully paid, but they certainly are. You hope to be treated extremely well no matter what, but if you're not, then you at least hope to be being paid well for it. But obviously you want both. So, but yeah, hopefully this trend continues. I know another global airline, Etihad, is not. They are continuing with pay cuts, so they are not ready to throttle back up to full salaries. So, at least for right now, I guess we'll have to kind of wait and see.
Yes.
All right, so in our EVTOL segment today, first we're going to talk about DuFour. They have got a tiltwing concept that they say comes with less risk than other designs because this one has been sort of proven out over the years. Very similar to a Canada Air CL-84 Dynavert, which was manufactured between 1964 and 1973. So for me, if they made a successful plane back, 50 odd years ago or 60 odd years ago, then that does lend some positive feelings for me. If they could do it then with all the technology we have today, then we could certainly make something work here. So it's a shiny new prototype. Looks like a standard helicopter. Obviously has this big long wing with 6 propellers that tilts up for vertical takeoff and then tilts down to an extent. Alan, with these tilt wings, is this going to tilt? It's not going to tilt down completely because this is not a plane. This is more of a helicopter. But what do you know about this design?
Well, at least what I've seen of it online is that the wing actually gets to a vertical. There's a fixed. The motors are actually fixed to the wing, and the wing tilts, right? So as the wing tilts up, you get this vertical helicopterish takeoff system, and then it transitions forward. The little trick here, and I think why they could do it back in the 60s and 70s, is the relationship between the airflow coming off the propellers and the wing remains fixed, right? The only variable in this is sort of the forward or vertical tilt of the wing/motors. if you're doing it non-electric, it gets really complicated because you got these motors and you got all this inertia and things are spinning and it can get a little more complicated. But in some of these more simpler designs, and then we can use computers to make things simpler, there is some aerodynamic simplification that happens. So instead of moving the propellers relative to the wing, everything moves together, which is probably a little more solvable of a problem. The question is, mechanically, do you want to do that? Does it add a lot of extra mechanisms and actuators and control system laws and all this other pieces that back in the 70s you would just had a big lever, you would have pulled it and the whole mechanism would have turned. Now you're going to do a bunch of hydraulic electric actuators to do it. And do you create additional fault modes? Are there bad things that happen here? Are there additional load paths that can get stressed over time? Because I think in any EVTOL, especially so the variety of we're going to see here in the next 2 to 3 years, they're all taking different tacks, Dan. They're all got different approaches. And we don't really have any data on structural capability. Like what does this thing look like structurally, like with the 737 and the Viasat thing? You don't really know because you haven't. The air loads are different. The way it flies is different. Are you going to see aircraft that have been certified struggle because of additional inspections, because they're finding cracks and all these fatigue paths? I think that's a very open avenue at the moment, just because we don't know what we don't know. We haven't flown a lot of aircraft that have all these unique motors moving, propellers twisting kind of designs. We don't have any history on it. And the one thing about the FAA is that, and EASA for that matter, is reliability and showing that you got a very reliable system. And a lot of that has to do with flight history. And if you don't have any flight history on the design, you're just learning as you go, which is not a great way to do it. The FAA is giving more latitude on these Part 23 smaller aircraft, but still, there's going to be winners and losers based upon how reliable the system you've created. And Dan, I think it's a lot like the Elon Musk on the SpaceX, where they have a different design than like Jeff Bezos does, or what Boeing is doing on the United Launch Alliance. They all have slightly different variations on the same concept, like going into space. Right? We all have our little approaches to it. Some of them work, some of them don't. And really, the only way you can find out is to start flying them, launching them, and then figure it out from there. And even in the Musk situation with SpaceX, how many spacecraft hit South Texas and exploded recently when they didn't have the really control laws figured out? A lot, right? And you don't want to see that with aircraft in particular, which I think in the eVTOL world, we're not putting pilots in them, in most of them yet. So if they do go haywire and you have some structural or control system problem, if it hits the desert, it hits the desert. It's not great, but at least no one's getting injured. And I think that's one of the reasons why is that we don't have a lot of experience on these type structures yet.
Yeah, and that is a positive, where it seems like a lot of these eVTOL companies, Joby, Volocopter recently. Well, Volocopter did their tests with people inside, but they seem to mostly all have the capability to fly by themselves. So that really takes a lot of the risk out of it, which is great.
Right, which is smart.
So last on the docket today, Archer Aviation, which has obviously been in this big public battle with Wisk. They've made an announcement that they're going public. Of course, they committed to, well, I'm not sure if committed is the right word, but they had partnered with Atlas Crest Investment Corp, which is a SPAC, but they are planning to go public in a month with them through that SPAC merger. And with all the legal issues that have been going on, they could have said, yeah, we're going to pull out, we're going to wait on this, but they've said, no, we're going ahead. We're good, and we're going to do this thing and go public. So, Alan, do you feel like this is the right move for Archer Aviation?
I think you have to, because the amount of money you have to raise, which is astounding amount of money. You're talking about $1 billion. That's what you need to get successfully through the certification effort. And if you're going to do this Uber flight type of passenger service, you're going to need that kind of cash. And I don't think unless you make it public, you're going to have the opportunity to raise that kind of money. There's always people willing to invest in these things, but when you're talking, let's just back this out. If you needed to raise $100 million for a project, I think in today's environment, it's not super hard to go do that, depending on what the marketplace is. When you're talking about $1 billion, that's a little different thing. And I do think you're going to need outside investment. You're going to need a lot of small investors or institutional investors to come in, and they didn't have a vehicle to go do that. Now they do. And one of the interesting thing is there's that whole push for SPACs, and it seems like a lot of aerospace companies jumped into that SPAC method of getting to the marketplace and getting it public. That's how they're doing it. And now it seems like it's getting poo-pooed by the industry. There's a lot of other types of companies have looked at SPACs and been told, no, you're not going to do that. So aerospace is such a conservative marketplace. Typically, it's weird to see it in a place where other highly aggressive type businesses can't get into a SPAC because it's not looked upon favorably at this particular moment. And there's a lot of reasons to do it, and there's some not to do it. But wouldn't you think it's more Silicon Valley-ish things be SPACs because it's a way to jumpstart the cash flow for the business? And aerospace typically has been so conservative, they've never done it. And it's like there's been a reversal, this weird financial reversal on small aircraft going to SPAC, other internet-type businesses not going SPAC. That's fascinating. I just watched. I've been watching Slide Bean videos when they're talking about SPACs and how SPACs are not looked upon kindly at the moment. And that's weird because there's a couple $1 billion in that marketplace today. So no matter what others think of it, it's going to be around for a while. And even the SEC have you seen some things from the SEC looking at SPACs going, we're not so sure this is a good idea? It's a little too late for that. The SEC, in my opinion, needs to be ahead of that by like a year or two. Feels like we're in this odd place where the SEC is playing catch up to what the industry is doing and not really having any input into it. It's like it happened. SEC is coming back and go, oh, maybe not. That's a good idea, but it's sort of too late. What are you going to do? You can't undo those large investment groups because they're already formed. I guess we're going to see how this goes, but it just feels very un-aerospace at the moment, and maybe it's the right thing to do. Maybe we should have been doing it years ago. We're just going to have to see how it goes.
Yeah, well, I know it seems like there's a timeout with a lot of these SPACs where they have 2 years from when they. I don't know if it's whether they announce a merger or when the SPAC comes into existence. When they announce
existence into,
they have to get investment.
Right, exactly.
And if they don't get to that, at the end of that 2 years, if they haven't merged, then they have to give the money back to investors. However, beyond just the 2 years, it seems like if they don't get this, find a dance partner pretty quick, that they just sort of they're not hot anymore, and no one wants to dance with them. So it's like there's a very maybe 6 months or so where they need to find their acquisition. Otherwise, it's just well, I don't know. It's almost like they're damaged goods or something. So it seems like there's beyond the 2 years, there's an even faster ticking clock for them.
Right, where they got to get going. But am I off on this? But that little window of opportunity is hard for investors because let's say there's 100 SPACs being created and none of them have connected up with a future company. Which one do you invest in? You just don't know. And it's sort of like going to Vegas and playing the roulette table. You may put your money down on a specific number and it may come up, but who's going to invest in the next EVTOL company? Who knows? Because there's a lot of SPACs that are out there they could use.
Well, that's going to do it for this week's episode of the Struck Aerospace Engineering Podcast. Thanks so much for listening. Be sure to subscribe on Spotify, iTunes, Stitcher, YouTube, wherever you listen to your podcasts. And we will see you here next week on Struck. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.